This is your Chapter 4 test review sheet, the solutions to all of the problems. So let's get started. These first three problems, we want to make sure that you understand your rules of exponents, and all of them are being used in these first three problems. So for problem number 1, I always like to simplify within the parentheses first, and that means starting with 8 over 24. That simplifies to 1 over 3. When I simplify variables that are being divided, I just write down the variable and I subtract the exponent. So 2 minus 3 is negative 1. And then the same thing here, I'm going to write down y, and then the way I simplify these is to subtract their exponents. 3 minus 2 is positive 1. Okay, so all I've done so far is simplified within the parentheses. Now I'm going to raise every individual number or variable that's being multiplied. I'm going to raise each one of those to the 4th power. So starting with 1 to the 4th power is still 1. X to the negative 1 raised to the 4th. When a power is being raised to a power, this is when you multiply those powers together. So that's going to make x to the negative 4. And here 1 is being raised to the 4th. 1 times 4 is 4, y to the 4th. And down below, 3 raised to the 4th is 81. Okay, I never want to leave an answer with a negative exponent. So this x to the negative 4 can be made positive by moving it down to the denominator. So when I move it down to the denominator, it just leaves y to the 4th in the numerator times 1. I don't really need times 1. And then in the denominator, in the numerator, you'll have y to the 4th. In the denominator, you'll have 81 x to the 4th. So the way you can simplify these negative exponents that are in fractions like this is just to relocate them to their other place if it's negative in the top. And it will always be negative in the top to begin with when you do this subtraction. So when I do this rule of subtracting exponents, the negative exponent will always start off in the top, but then if I need to change it to positive, I just shift it to the bottom. All right, and so we are done, and that is our answer for number 1. For number 2, I'm going to follow a same type of strategy. I'm going to simplify within the parentheses first. So 5 over 1, can't really reduce that, of course. But when I simplify these two a's, remember I'm subtracting the exponents when I'm dividing. So it's going to be a to the negative 7 minus 1 power, which is negative 8. And b is going to be to the 2 minus negative 6 power. 2 minus negative 6 is positive 8. And I didn't really need this divider, but if you want to, you can go ahead and put 1 down there. Okay, now I'm going to take care of the negative exponent on the outside. And the way I do negative exponents, if I want to change them to positive, is I just flip over or write the inverse of the fraction that's below it. So I'm going to flip over this fraction. Just like it looks, it's just going to be flipped over. And once I've flipped the fraction over, I can now change this exponent to positive. Okay, now I'm going to do much like I did over here. Everything inside the parentheses is going to be raised to the 3rd power. 1 to the 3rd is still 1. 5 to the 3rd. 5 times 5 times 5 is 125. When I raise a to the negative 8 to the 3rd, remember when a power is raised to a power, that's when you multiply exponents. So that's going to start off as a to the negative 24. Okay, but remember we don't want to leave a negative exponent in our answer. So instead of having a to the negative 24 in the denominator, I'm going to move it up to the top as a to the positive 24. All right, and down here I have b to the 8th being raised to the 3rd, and that makes b to the 24th. And once again, you don't really need 1 times anything, but if you left it like that, that would be okay. Don't really need the parentheses here now that I've taken care of this exponent. And so that ends up being my final answer, a to the 24th over 125b to the 24th. Okay, let's take care of number 3. Remember PEMDAS, if we're simplifying, we go in this order and we would do exponents before we multiply. So before I can multiply these two together, I have to take care of this exponent. And when I take care of that exponent, raising both of these, remember both of these really have an exponent 1. And so this is that same rule of a power being raised to a power. That makes a to the negative 2. You multiply these together, and then b to the negative 2. Okay, now that I've taken care of this, now I can use the rule of multiplication. So when I'm multiplying like variables, this is when I add the exponents. So I'm going to write it out just like it would look. It's going to be 1 single a raised to the 2 plus negative 2 power. And then that's going to be multiplied times b, and that's going to be raised to the 3 plus negative 2 power. Okay, well this is going to be a to the 0. 2 plus negative 2 is 0. And this is going to be b to the 1. 3 plus negative 2 is 1. Well, a to the 0 is 1. Any number besides 0 that's raised to the 0 power is just 1. And of course, b to the 1st is just b. And so my final answer for number 3 is b. Okay, let's take care of simplifying polynomials. And this first problem involves subtraction. And so I would recommend that you treat this as your first move being distributing negative 1 to these right 3, the second group. So I'm not really doing anything yet to the left group. But to get rid of the parentheses, distribute negative 1 to each term. So negative 1 times positive 3x squared, negative 1 times negative x, that's positive x, and then negative 1 times 4. And now I'm just going to group like terms. I'm going to put like terms together, adding or subtracting the coefficients of like terms. That's how we put them together. So some of you are still stuck on adding exponents here. The only time I add exponents for variables is when I'm multiplying. I am not multiplying here. I'm adding. So I'm going to add 5x squared plus negative 3x squared. And that makes positive 2x squared. I'm adding 3x plus 1x. 3 plus 1 is 4x. And now I'm adding negative 7 plus negative 4. And negative 7 plus negative 4 is negative 11. And so that's my answer for number 4. For number 5, before I can add, remember PEMDAS says before you do addition, you have to do multiplication. And so I'm going to distribute, distributing 2cd times 3c, and then I'm going to multiply it times negative 4d. So distributive property. 2 times 3 is 6. C times c is c squared. Remember, if I'm multiplying, that's when I add the exponents. And then I've just got this d that multiplied by 1, basically. And now I'm going to multiply 2cd times negative 4d, and that makes negative 8cd squared. All right, now let's do the same thing over here. Distribute 4d. 4d times c, that's 4cd. And then 4d times 2d. 4 times 2 is 8. D times d is d squared. Okay, so much like this other problem, I want to try to combine like terms. Well, as I look across this, Like terms have to be same variable and the same exponent. Well, I don't have any c squared d terms to match up with this. I don't have any cd squared terms other than this. No other cd's, no other d squares, so I'm done. That's my final answer, since I can't combine like terms. All right, for number 6, this is multiplication. And so we're going to do the FOIL method. Really doesn't matter how you group these, but it does work out better if you group these first two together first and use FOIL. So I'm going to multiply first together, r times r, that's r squared. Outside, r times s, positive. Inside would be negative rs. And then the last would be negative s times s, that's negative s squared. Of course, these would just make 0. And so multiplying these two together using FOIL, I got r squared minus s squared. And now I'm going to multiply this other binomial, and we're going to do FOIL again. So you're just going to do the FOIL method twice. Okay, first together, r squared times 3r. Just think of this as a 1. 1 times 3 is 3. And then r squared times r, we're multiplying, so we add the exponents together. That's r to the third. Now let's do the outside terms. That's going to be negative, positive times negative. 2 times 1 is 2. I don't have any other r variable here in this term, so it's just going to be r squared and no s in this one, so it's just negative 2r squared s. In the middle, it's going to be negative 3r s squared. And then for the last, negative times negative is positive. 2 times 1, the coefficient here is an invisible 1. 2 times 1 is 2. And then when I multiply the s's together, I add the exponents, and it makes s to the third. Okay, and then I see if I have any like terms, and doesn't look like I do, because they have to have the same variable and the same exponent. So these look all of them differently. So that ends up being my answer. Number 7. Pascal's triangle. You need to know how to make it first. Start with a single one. Below that, some of you are skipping this second row. There should be 1 number, then 2 numbers, then 3 numbers, then 4 numbers, and so forth. So start with a single one, and then don't forget you need 2 ones, and then from there it's just a pattern. Every row starts and ends with 1, and then to get the middle part you just look above and add. 1 plus 1 is 2. Start with 1, 1 plus 2 is 3, 2 plus 1 is 3, end with 1. Start with 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, end with 1. So to know which row you need to do this particular expansion, remember, whatever exponent is above the binomial, your answer should be one more term than that number. So when I'm finished expanding this, I should end up with 5 terms. So one easy way to remember which row of the triangle do I need, pick the row that has one more number than whatever the exponent shows. So this is my row, and here's how it works, expanding using Pascal's triangle. So I'm going to show my work, and then we're going to simplify it to get to the final answer. So it begins with taking this first number from the row, which is 1. I'm going to multiply. Looking inside my parentheses, I'm going to have 3m, and it's going to start off being raised to the 4th power, still multiplying, and then I'm going to take the second of the terms, negative 2n, and it's going to start off at the 0 power. All right, now let's add, and next number from the triangle, 4. 3m, the first term, is going to drop down to the 3rd power, and negative 2n is going to go up to the 1st power. Okay, I think I'm going to erase my row here now that you know which one it is. Okay, my next number in the row is 6. Multiplied times 3m, that's going to be now to the second power. And negative 2n is going to go up to the second power. First one goes down, second one goes up. All right, next number from the triangle is 4. 3m goes down to the first power. Negative 2n goes up to the third power. And then finally, we'll just stick it down here. The last number from the row that we wrote down was 1. 3m goes all the way down to the 0, and negative 2n will go all the way up to the fourth. So the first term starts at, in this case, 4 and ends with 0, and the second term starts at 0 and ends with 4. Okay, now let's clean this up, and we'll get our final answer. So notice, to get terms, we multiply. I notice some of you are trying to add. We're adding between the terms, but to get to these terms, to see what they are, we multiply all of this together. So I'm going to write my final answer in blue. So I got to do 3 to the 4th and m to the 4th. That's 3 to the 4th is 81, and of course that's m to the 4th. And negative 2n to the 0, we talked about this earlier, any number besides 0 raised to the 0 power is just 1. So it's like 1 times 1 times 81 m to the 4th. So my first term is 81 m to the 4th. All right, let's work on the next term. Before I multiply, I have to do these powers. So 3m, all of this raised to the third. Well, 3 to the third is 27. And then m to the third. And then, of course, if I raise negative 2n to the first, it's just negative 2n. Now I got to multiply all of this together. Okay, so you might want a calculator here. 4 times 27 is 108. And then we're going to do 108 times negative 2, and that's negative 216 m3n. All right, now let's move on to the next. So it's going to be 6. Simplifying this, remember it's 3 squared times m squared, that's 9m squared. And then negative 2 squared is positive 4n squared. Okay, now we're going to multiply 6 times 9, that's 54. And then 54 times 4. I don't have my calculator out in front of me. I want to make sure I get this right. That's 216, and it's positive. 216, and then m to the second, n to the second. All right, let's work on this next term. 4, and then if I raise 3m to the first, that's just 3m. And if I raise negative 2n to the third, I get negative 8n to the third. All right, so multiply the coefficients. 4 times 3 is 12. 12 times negative 8 is negative 96. And m is to the first, n is to the third. And we're almost done. We just got this one more term. 1 times 1, 3m to the 0 is just 1. And I just have to do negative 2 to the 4th. That's positive 16. And then n to the 4th. And that ends up being my final answer, expanding using Pascal's triangle. All right, number 8. Another way of expanding is using the binomial theorem. We're not going to do the entire expansion. That would be 9 terms altogether. We just want to know, of the 9 terms, what's the 7th term? So the binomial theorem uses a combination as a factor. And every term has this combination factor in front of it. So for the 7th term, it would have whatever the exponent for the binomial will be on the left. And then the way to remember what goes on the right is it's going to be 1 less than whatever you're asked to find. So since I'm asked to find the 7th term, I'm going to put 6 here. if you think about it, it's because with the binomial theorem, we always start at 0. So if we started at 0 with the first term, by the time we got to the 7th term, that number would be 6. So that's the reasoning behind it being 1 less than whatever we're asked to find. And we're multiplying all this together. So my next term, I'm going to do 2a. And I'm going to raise 2a. This first exponent will be the difference between these two numbers. So if you just do 8 minus 6, that's 2. The next term, negative 2b, you can remember that the binomial theorem always has the second number after c, the 6, and the second exponent always match. So there's various ways that you can make sure you got these exponents right. If you know that the second number after c and the second exponents match, you also know that these two exponents added together have to equal this one. So if you forget that, oh, how do I get this first exponent? Well, remember that these two match, the second one after c, the second number, and the second exponent. And remember that these two exponents have to add up to the overall exponent, and then that'll help you remember how to get the exponent for the first term. All right, and now we grab our calculator and we do 8c6. So on your calculator, when you do 8c6, that should be 28. Then when you raise 2a to the second power, that's 4a squared. When you raise negative 2 to the sixth, negative 2 to the sixth is 64, and then b to the sixth. And now we just multiply the coefficients together. So if you have your calculator, you can do 28 times 4 times 64. And that's 7,168. And then a to the second, b to the sixth. That's our answer for number 8. For number 9, we're going to use the binomial theorem to help us with some probability problems. So by being told that it's just as likely for a pitcher to throw a ball as a strike, that just means that there's a 50-50 chance of each. So I'm just going to call, doesn't really matter which one you pick, 50% that he's going to throw a ball, 50% that he's going to throw a strike. So the problem wants us to find the probability that 12 of her first 15 pitches are strikes. All right, so I'm going to raise the strike percentage to the 12th power because it says the likelihood that 12 are strikes. Easy to remember. And I'm throwing 15 pitches altogether. So if I throw 15 pitches and 12 of them are strikes, that means 3 of them have to be balls. So these two exponents should add up to the total number of whatever the problem says took place. And this is all being multiplied together, just like we did up here. This is just one term of a binomial expansion. And the combination factor, once again, remember that these two exponents added up should be on the left of c, just like they were up here. 2 plus 6 is 8. 3 plus 12 is 15. And the number to the right of c should match the second exponent. And now you're ready to go to your calculator. And so let's do, trying to find that on my calculator. All right. So we're going to do 15 and 12. So that equals 455. Now you can do this all, I'm using my iPad calculator, so it's a little bit different, but you can do all of this at once. So let's see, 455 times 0.5 raised to the third times 0.5 raised to the 12th. And it shows this big long decimal 0.013885 and so forth. We're going to move the decimal 2 places to the right. So that makes it 1.3885. And that's the percent form. And we're going to round that to the nearest hundredth. That means 2 decimal places. So remember your rounding rules. We move the decimal 2 places to the right to change it to percent form. And it's going to show 2 decimal places, but that means 0.388. So since 8 is bigger than 5, of course, that means I'm going to put 0.39. 1.39% is my answer for number 9. Okay, let's do some division and long division. So to set this up, I'm going to have x minus 2 dividing into 2x to the third minus 7x squared plus 7x minus 2. When I divide, I'm really just dividing this first term into this first term. So if you need to, just go off to the side somewhere and break this out into something simple. It means 2x to the third divided by x. And if you remember your exponent rules, when you're dividing the same variable, you subtract the exponents. So that becomes 2x to the second. So I'm just going to match it up with the x to the second in the problem. And now you multiply. So 2x to the second is going to multiply times both of these. It's the distributive property. 2x squared times x is 2x cubed. And 2x squared times negative 2 is negative 4x squared. And with long division, you always subtract. So the x cubes will become 0. And this, you got to be careful here because it's negative 7 minus negative 4. Subtracting negative 4 means addition. So negative 7 plus 4 is negative 3x squared. Bring down the next term and then repeat that process. This time we're dividing negative x into negative 3x squared. Okay, it's just the first term divided by the first term. So off to the side you could do this. Negative 3x squared divided by x. And if you simplify that, you get negative 3x. And now repeat the distributive property. Negative 3x times x is negative 3x squared. And negative 3x times negative 2 is positive 6x. Subtract. The x squares are going to become 0. And now I'm doing 7 minus 6. 7 minus 6 is 1x. Bring down the next term, and we're going to go through this one more time. So I divide first term, x, into first term. So any number or variable divided by itself is just 1. So it's going to be positive 1. And now distribute 1 times x, 1 times negative 2, subtract, and this time we get a remainder of 0. And so my final answer ends up being this quadratic trinomial. Okay, let's try this other one. This time we're going to be dividing by a trinomial. And you should always pay attention to whether or not you're jumping over exponents. So if you notice, I start with 4, and then I go 3, 2, 1, constant. So none of the terms are missing. They're all in succession, just decreasing by 1. So we don't have to plug in a 0 in a certain spot. All right, so once again, just like we did before, first term into first term. Okay, so we're back to division, and as I said before, first term into first term. So we divide x squared into x to the fourth. So it's like this, x to the fourth divided by x squared. and that goes x squared times. So I'm going to put x squared above the x squared term. And now I'm going to distribute. X squared times x squared is x to the fourth. X squared times negative 5x is negative 5x cubed. And x squared times 4 is 4x squared. Then I subtract, and the x4's cancel. Negative 4 plus 5. Remember, this is minus negative, so it's really addition. Negative 4 plus 5 is 1x cubed. Negative 7 minus 4 is negative 11x squared. And then bring down the next term. And then repeat. So now you're dividing x squared into x to the third. So it looks like this. X to the third divided by x squared is x to the first. You subtract the exponents. Now multiply x times both, or all three of these terms. X times x squared is x cubed. X times negative 5x is negative 5x squared. And x times 4 is positive 4x. Subtract. The x cubes will cancel. So negative 11 plus 5. Negative 11 plus 5 is negative 6x squared. And 34 minus 4 is 30x. And then bring down the last term and repeat. So x squared goes into negative 6x squared, negative 6 times. And negative 6 times all three of these. Negative 6x squared plus 30x minus 24. And once again, it looks like we're going to have a 0 remainder. So my answer for number 11 is here, x squared plus x minus 6. So a couple of big takeaways on this. Again, be on the lookout. It didn't happen on this problem, but be on the lookout for terms that where exponents are missing. You will have to put in a plus 0 and then whatever missing exponent there is. For example, if this term was not here, then I would be putting a 0 plus 0x to the third in that spot. So that's always something that you need to be aware of. And if you have time, some of you finished test early. If you have time, you can always check. And if you do multiply, in this case, x minus 2 times 2x squared minus 3x plus 1, you should be able to multiply those together. And if you get this polynomial, then you'll know you've done the right thing. So just some suggestions. Be careful when you're jumping over exponents. And then another way that you can check. If you do end up with a remainder, I know that neither one of these had a remainder, but let's just say, for example, we did end up with some number remainder. I'll just make something up. Maybe it ended up with a 39. Then you're going to just say, in this case, I know this doesn't match, but just pretend like we had a 39 remainder. We would have x squared plus x minus 6, and then we would put plus 39 over x squared minus 5x plus 4. Okay, or if it had been some sort of linear binomial, 39x plus 1, then it would just look like this. So just wanted to give you an idea. I know these did not turn out to have remainders, but it could happen on the test where they do. And I just want to make sure that you're clear on how to handle remainders when they do pop up. All right. So our next problem, we've already done this one, so we can just skip on over to the next problem. In our next problem, we will show you the difference between long division and the synthetic division process that you should also be really good at doing. Let's do one more long division problem. We did that one already, so sorry about that. Let's do synthetic division. So with synthetic division, I'm dividing by x plus 1, And that means, remember, this can be a little tricky. That means the opposite number, it's the number that actually make this become 0, goes in the house. And then to the right, I'm going to put 1, 4, -4, -7. And once again, double check and make sure that you don't jump over exponents. You started at exponent 3, then you see exponent 2, I see exponent 1, and then constant. So no need for a filler 0, but be careful. All right, so bring down the first number. Nothing ever gets written here. Multiply times the number in the house, and then with synthetic division, you're adding. Okay, so 4 plus -1 is 3. Multiply 3 times -1, that's -3. Add -7. Multiply gives you +7, and we get a remainder of 0. So remember, if I divide into third degree, which I did, then this result should be second degree. So that means that 1 is in front of x squared, and 3 then will be in front of x. And then -7 is just a constant. And this always represents the remainder. And since there is no remainder, there's our answer. Okay, so for 13, to set up synthetic division, I'm going to put +2. And I start with exponent 4. The coefficient of that term is 1. But you notice there is no x to the third. It goes straight from 4 to 2. So in place of that x to the third term, I'm going to put a 0. Then a -6. Notice I went from x squared, and there is no x to the first, so I need another 0 in that x to the first place, and then -27. All right, let's start synthetic division. Nothing goes here. Bring down the first number. 1 times 2 is 2, and then you add. 0 plus 2 is 2. 2 times 2 is 4, and then you add. That's -2. -2 times 2 is -4. Add, and then -4 times 2 is -8, and you add. So remember, I divided into fourth degree. The exponent was 4, so this has to be in front of x to the third. It's always 1 degree less. 1x to the third, and then 2x to the second, minus 2x. We're just going down by 1, and then -4 has to be a constant. And then I'm going to be subtracting 35 over what I divided by, x minus 2. And that's my answer for number 13. Okay, moving on to problem number 14. This is using synthetic substitution. So what this means is instead of doing substitution like we're used to doing, which would look something like this, if I'm going to evaluate p of -2, then what we've done in the past is we've replaced x with -2 in this function, and then we go to our calculator and we see what the output is. So this is one way of doing an input, -2, and then seeing what the output would be. So that's what we did in the past. Well, synthetic substitution says this: take the number just as it's given. You don't have to worry about changing the sign here if you're evaluating a function. Put that number in the house, and then to the right of that, we're going to put 1, -5. Since there isn't an x squared, we're going to put a 0. Then we go with the x coefficient, 4, and then the constant. So just be careful that you filled in the necessary 0 wherever there's a missing exponent, and there's a missing x squared right in here. So we put a 0 in that spot. And now we're going to do synthetic division, and just like we did in the previous problem. So we bring down the 1, multiply, add, multiply, add, multiply, add, and 48 and 54. So whereas the old way, whenever we did this in our calculator and then whatever the result was the answer, if you did this in your calculator, you would have gotten 54. Well, synthetic substitution says use synthetic division, and whatever the remainder is the answer. This is called the remainder theorem. So that's the answer for the p of -2 part. And so now we'll just do p of 4, much the same way, same numbers to the right. Leave a space and bring down the first number. Multiply 1 times 4 and then add. Multiply and then add. Multiply and then add. And multiply one more time. -12 times 4 is -48. And when you add these, you get -42. So my answer to p of 4, if I input 4 into this function, I'll get an output of -42. So that takes care of number 14. 15 through 18, we're basically matching the functions down below, a, b, c, and d, to the graphs that are provided. So this is an exercise in seeing if you understand that the lead coefficient, all right, so let's just go ahead and identify lead coefficients here. Here it's +1, also +1. Here it's -2, and here it's -4. Those numbers, whether they're positive or negative, will tell me if the function goes up on the right side. So according to this, 2 of the functions should be going up on the right side because these 2 lead coefficients are positive. These 2 they represent functions that should go down on the right side since the lead coefficient is negative. All right, so it's the degree, which is the largest exponent. So here the degree is 3. Here the degree is 4. Here the degree is 2. And again, degree 3. The degree will help us with the left side. So let's just do letter A, for example. The graph of this should go up on the right. And since the degree is odd, 3 is an odd number, then it should do, just remember, odd opposite. Odd degree, then it should do the opposite on the left side. So if it goes up on the right, according to this, it should go down on the left. All right, and there's only one graph that does that. This one goes up on the right, down on the left. So I'm going to put the letter A for number 18. All right, this one also goes up on the right, but it's an even degree, so it's going to do the same. If odd does opposite, then even will be the same. All right, so I'm looking for a graph that goes up on the right and also up on the left. Well, the only one that does that, up on the right and also on the left, is number 15, so I'm going to put a B for that one. Okay, this one should go down on the right, and according to the degree being 2, it should also go down on the left. It should go down in both cases, down on the right, also down on the left. So I'm going to put a letter C for number 16. And then, of course, we only have one left. But just to make sure you understand, it should go down on the right because the -4, the number in front, the lead coefficient, will tell you about the right side. And then look at the overall degree to help you with the left side. And so since the degree is odd, if it goes down on the right, it should go up or opposite on the left. And that takes care of 15 through 18. All right, number 19, here's another evaluating a function, but this time our input is not just a number, it's a monomial consisting of a number and a variable squared. But the same idea as what we've done in the past, sort of like what we've done in function cornhole. Wherever I see x, I'm going to replace it with 4a squared, and this is all cubed. And then here's another x, so it's going to be replaced with 4a squared plus 1. Okay, so remember, I got to do the power first, and then it's like multiplying by -1. So this is the opposite of whatever x cubed is. So it's the opposite of, and remember, you got to do 4 cubed, 4 times 4 times 4, that's 64. And then here's that rule again, when a power 2 is being raised to another power. This is when you multiply those together, and it makes a to the 6th. And then we're going to be adding 4a squared and then plus 1. If we did have like terms, we would combine them, but none of these terms are alike. They don't have the same variable and the same exponent. So this ends up being my final answer for number 19. All right. Number 20. This is a repeat from, we've had this on several tests, but we're still not doing great with them. So I'm hoping that with this test, this problem will improve. So first of all, we're writing an equation for a particular line. All right, so here's the information for a line that we're supposed to write the equation for. It should be y equals mx plus b. And all we know is the line goes through this point, and it's perpendicular to another line. Well, let's find out what this line is that we're given, what the slope of that line is. And the slope of this given line is just 4. All right, easy enough. So now turning to the line that this mystery line that I'm supposed to write the equation for, I know it goes through this point, so that's going to be x and that's going to be y. But what do I plug in for m? Well, I have to remember that when two lines are perpendicular, they have opposite reciprocal slopes. We're still not really catching that. Opposite reciprocal. So let's take those two things and apply it to the number 4. The opposite of 4 is -4. So right now, if I just stopped, I would have the number -4, or you could think of it as -4 over 1. The reciprocal of -4 over 1 is -1 over 4. So this needs to be the slope that I use for this line that is perpendicular to this. All right, and I do not use any other information from this equation. I'm going to mark it out. I'm finished. That equation has served its purpose. I'm going to use 10 for x, 2 for y, -1/4 for m, and that's going to help me find out what b is. So let's see. Y, which is 2, equals m, which is -1/4, times x, which is 10, and we're going to solve for b. All right, so we got to do this multiplication here. So this starts off as -10/4. Let's come over here and do a little work. But -10/4 can be reduced. If I divide both of these by 2, I get -5/2. So I'm going to treat this, instead of -10/4, I'm going to reduce it down to -5 over 2 plus b. Okay, well, I'm going to have to add 5 over 2 to both sides. Pretty obvious that to undo this, I'm going to have to add. Right now it's being subtracted. And the problem becomes, I've got to add 5 over 2 to 2. It would be great if 2 was also a fraction that had a denominator of 2, so I could add them together. Well, that's easy enough to do because 4 over 2 is equal to 2. Now they have the same denominator. It's still equal to 2. So now when I add 5 over 2 to both sides, 4 over 2 plus 5 over 2 gives me 9 over 2. So b is 9 over 2. So now I'm going to finish it off, just clear out a space here to come up with my final answer, which should be y equals mx plus b. So y equals m, which we concluded is -1/4, x, plus b, which we just found is 9 over 2. And that's my final answer for number 20. All right, so this word problem, Bill can have digital photos printed at the online store, 15 cents per photo and $2.70 for shipping. So it sounds like the $2.70 is going to be basically a flat fee regardless of how many photos are printed. So that's one option. So he could also go to the local store and have them printed for a different price per photo. So the key to me in this problem is this 15 cents per photo, 25 cents per photo. That tells me that if I'm looking at the online store and I'm supposed to write an equation, here's online store, I'm supposed to write an equation, and this is going to be linear, y equals mx plus b. So y is going to be how much I'm going to pay. How much money is it going to cost? And since it's given by per photo, that tells me that I'm going to be multiplying 0.15 times something, and that something is going to be the number of photos that are actually being developed. So I'm going to let x be the number of photos, and y will be how much I pay. And so really what you pay really depends on how much or how many photos you turn in. And then we've got this shipping charge that gets added on. That's going to be involved in the cost. So that takes care of the online store. And then let's do the local store. Y is still cost. X is still number of photos. But this time it's a little different. It's going to be a quarter for every photo we take. All right, so that takes care of letter A. These are two equations that represent cost for our two different options, the online store or the local store. So letter B says, for how many photos is the printing cost the same? Well, that's just another way of saying, take this system, this is called a system, and solve for X. Okay, it wants to know how many photos would these be the same. All right, so what we're going to do is take the, you can do this either way, we'll take the local store, which is 0.25x, and let it equal to the other equation. This is called solving a system, and we're using the substitution method. Now, if you also decided to solve this using elimination, that would be fine. But this is substitution because if y is 0.25x, then it's okay to substitute 0.25x in for the other y, and that's what I did. So the goal is to find x. X represents number of photos, and that's what this question wants to know. And I've let these equal each other, and that's going to give me how many photos will represent the cost for the same at both stores. All right, so let's divide by 0.15 to get x on one side only. So 0.10x is 2.70. And then if I divide by 0.10 to get x by itself, I get x is 27. So the bottom line for this is if I have 27 photos that I have to print, it really doesn't matter which one of these I go to have them printed. Either one, for 27 photos, they're both going to charge me the same amount. Now, I didn't solve for the amount. That's what y is. So all I've found out is for how many pictures will they charge the same. So at 27, sometimes we call this in business, this is kind of a break-even point. So for 27, it really doesn't matter which one you pick. If cost is all that matters to you, you'll pay the same no matter if you choose the online or the local. Now letter C, it's a little different question. When is it best to order the prints online? And when's it best to use the local store? Well, just to do a little test, let's change this number. Let's pretend like we only wanted 26 photos. Okay, so for the online store, if I'm just printing 26, let's see how much that would cost. So I do 0.15 for every picture, and I'm printing 26 pictures, and the online store is going to make me pay the extra $2.70 for shipping. So let's go to our calculator, and let's see how much we would pay for 26 pictures. So I'm going to do 0.15 times 26, and then add the $2.70 for shipping. So they're going to charge me $6.60 for 26, which is one less. Okay, well, let's do that same little test with a local store. If I just had 26 photos, how much would the local store charge me? So they're going to charge me 25 cents for every picture. I've got 26, and I don't have the shipping fee, obviously, because they're local. I don't have to do it online. So this time I'm going to do 0.25 times 26, and that's $6.50. Interesting. So to answer the question, if I have fewer than 27 photos, it looks like the local store is going to be the better option. They're going to be a little cheaper. So conversely, if I have more than 27 photos, then it's going to swing back to the online store. It's going to be the better option. So I'm going to say it this way, for less than 27, it's going to be cheaper to choose the local store. Obviously, then for greater than 27, I'm going to choose the online store. Okay, and that finishes off our answer for number 21. Okay, so these are just exercises, and do you understand how to find domain and range? Domain is X and range is Y. Domain is also known as input. Range is known as output. Those are the most commonly used letters or words for domain and range. So all I have to do for number 21 is list out the domain, and we typically do these lowest to highest. So I'm going to say the domain is -2, 5, and 6. And the range, also from low to high, would be -8, 1, and 3. And now determine whether each relation is a function. You're looking at the domain, and if you have a domain number that maps, this is called a mapping diagram. If a domain number is paired up with more than one range number, like if I had another 4 here, and the number 5 mapped not only to 3, but it also mapped to 4, then this would not be a function. But as it is, the domain numbers are only paired with one range number each. So this would be a function. Another way of looking at it is a simple way is look for repeats in the domain. All right, so here's number 23. Once again, domain is are the x coordinates, so I'm just going to go lowest to highest. I see -2, +1, and +4. Now I notice that 1 appears twice, but we typically don't list the domain or range elements more than once. So I think I got them all. -2, 1 twice, and then 4. And for the range, those are the y coordinates. So 3, going low to high. So that would start with going this way, -1, +2, +3, +5. Now this one, if you notice, there's a repeat. The number 1 appears twice in the domain. That makes it not a function. Another reason why it's not a function is it doesn't pass the vertical line test. A vertical line touches 2 points. If a vertical line touches more than 1 point on the graph, it's not a function. So that's our complete answer to number 23. And then 24, the domain will be -2, 1, 4, 8. And the range would be -4. Again, there's another -4, but we don't list them more than once. And again, for whether or not a relation is a function, you're looking at the domain. It doesn't matter that I've got repeats in the range. I'm concerned about repeats in the domain, and there are none, and so this is a function. All right, moving right along. We've done these a lot, and we're still not where I'd like to be on these, so I thought we would try it again. And basically it's just a review of graphing linear equations, but then we restrict the showing the whole line based on these domain restrictions. So let's just start with this. Let's just say we're going to graph y equals x plus 2. So that has a y-intercept of 2. Remember, this is y equals mx plus b. And there's a slope of positive 1. So I go up 1, right 1. Or if I wanted to, I could go down 1, left 1. I'm still on the line. Okay, so instead of drawing that entire line, that's what y equals x plus 2 is. I'm only going to show it for x coordinates on this line that are less than 0. Okay, and maybe, I don't know if this would help, just do a little table and input numbers that match this. So an x that would be less than 0 would be -1. So if I input -1 into this, I would get +1. All right, so here's -1, +1. And then if I input -2, okay, I can input any number that matches this. If I input -2, I get 0, and that's what this point is. So this little table kind of helps you see that really the very first or the far right point on this graph is going to be this point right here, -1, 1. But what about the thing that's a little bit confusing is what about -1/2 and what about -1/4? You've also got those in here. So to capture those, we're basically going to let the left end or the right end of our line be here at where y is 2. Okay, so here is where x is 0 on this line. And now I'm going to let the line show all of the x coordinates that are less than 0. And probably should just pull out my line draw tool, so let me do that real quick. And we'll do this first one in blue. Yeah, chose the wrong arrow. Sorry about that. Okay, so this is representing that line, but only for x coordinates that are less than 0. If I had gone to here, for example, that x coordinate is 1. And according to this, I can't show any points on this line where the x's are greater than 0. Okay. All right, let's do the next one. We'll do this one in red. Let's graph y equals 2x plus 5. Okay, y-intercept 5. And a slope of 2, up 2, right 1. Or if you want to, down 2, left 1. And we would keep doing that if we were graphing the entire line. But according to this, we're only graphing the line for x coordinates that are between 0 and 2. Well, here is where the x coordinate would be 0. All right, so anything to the left, I don't need these points. All right, this is another way of saying between 0 and 2. Well, basically, all we're talking about is this little segment. Here is where x is 0 on the line. Here is where x is 2 on the line. Okay, once again, maybe a table helps illustrate it. If I do x is 0, I get output 5. And that's what that point is right there, 0, 5. If I do input 2, I get output 9. 2 times 2 is 4, plus 5 is 9. And that should be that point. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so all I have to do really is show that little segment and that takes care of this one. So the blue one, the red one, and now let's do the green one. It's the line y equals negative x plus 1. All right, so we start at a y-intercept of 1, but this time we have a negative 1 slope, so that's down 1, right 1. Or we could do up 1, left 1. But for this line, only x-coordinates that are greater than 2. Okay, so let's just start with 2 as an input. And if we did 2, we'd get negative 1 plus 1. That's, I'm sorry, negative 2 plus 1, which is negative 1. All right, so that's this point right here. So according to this, we should only show the line going this way. This is where x gets greater than 2. Going this way, I'm doing x is less than 2. All right, so these green dots here are not needed. And since it doesn't say or equal to, then this is actually going to be an open circle. And so the line's going to keep on going in this direction. All right, and so now we just do domain and range, and we'll be done. So the domain, let's see, the blue starts here at 0 and goes forever left. So blue is taking that much of the x-axis. The red is going to pick up there and go this far. And then the green picks up there and goes forever in the right direction. So if you put blue, red, and green all together, you have all real numbers. Okay, now let's see about the y-axis. That's what range is all about. So the red only takes this much. That's all. Doesn't go forever and ever in both directions. We have this little gap here that's not taken by any of the three graphs. And then the blue starts here and then heads down. So the blue and the green are basically headed in the right direction, and blue involves the green. Well, the green picks up here, so it's kind of like it gets blue and green both cover all of that area. So to put all this together, I'm going to say that my range involves all y such that I only have these y's, and this is between 1, 2, 3, 4, between 5, 6, 7, 8, 9. 6, 7, 8, 9. Yeah, so the way I show between 5 and 9 is I put 5, and it's less than or equal to y, less than or equal to 9. Okay, and then the rest of it starts here at 2 and goes down forever. So I'm going to say y is less than 2, and it wouldn't be or equal to because it's an open circle. And that takes care of 25. Okay, 26 and 27. These are translations or transformations of parents. The parent function being represented here is y equals the absolute value of x, and the parent function for this one is y equals x squared. Absolute value, remember the v in value and the v in the function. That helps you remember what that one looks like. The big U to spell out the word squared. Anytime you see a big U, that tells you that it's the function for the y equals x squared. Okay, so let's take a look at 26. This v, the parent, started off here. Y equals absolute value of x has a vertex right here. So this vertex has been moved. It's the parent moved 2 places to the left and 1, 2, 3, 4 places up. And so the way I show that using translation equation is 2 to the left would be x plus 2 inside the absolute value bars. And then 4 up would be plus 4. And that's my answer for 26. So if you want to do left or right movement, put it inside. Up or down movement, put it outside. The inside is really the opposite of the way it looks. It looks like it should be minus because you went left, but you got to be careful with the inside. It's always the opposite. Vertical movement is not tricky. Plus means up, minus means down. Okay, well, 27 is very similar. It's just a different parent. So instead of the absolute value, we're going to do parentheses. And this parent has been moved 1, 2, 3, 4, 5 to the right. And the way I show that is x minus 5 quantity squared. And then 1, 2, 3 down, the way I show that is negative 3. Now, if you notice, the parent u, all parents open up. The parent u would do this. The parent v would do this from the origin. Well, this parent has been flipped over. And so that's called a transformation. It's called actually a reflection. And the way I show that is I just put a negative in front of the parentheses. So it would look like that. And if this v had been flipped over, I would have put a negative in front of the absolute value bar. So those are your answers for 26 and 27. 28, we have to do FOIL on these complex numbers to simplify. So 3 times 4 is 12. 3 times 3i is 9i, and that's positive. Positive times positive. Negative 2i times 4 is negative 8i. And then negative 2i times positive 3 is negative 6i squared. Okay, so I'm going to combine like terms, and then I always have to remember that I squared is literally equal to negative 1. So in place of I squared, I have to put negative 1. So I'm going to go ahead and put 9i minus 8i together. 9 minus 8 is 1i. And then I'm going to show it like this, negative 6, and then in place of I squared, I'm going to put negative 1. Well, now it becomes this, because negative 6 times negative 1 is positive 6. And now I add the real numbers together. 12 plus 6 is 18. And when you're writing a complex number, always put the real number first, followed by the imaginary number. 29, we're going to complete the square. So we've been doing a little practicing with that lately. So the first thing to do is to move this constant over to the right, and that means addition. And then we'll figure out what is that number that completes the square. So divide by 2, and then square that. So negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. The factored form of the left side would be x minus 1 quantity squared, and the right side would be 25. Then I do the square root of both sides, and don't forget plus minus. And now I'm going to add 1 to both sides, and this is a case where it doesn't always happen this way, but I can actually come up with 2 integer answers, because if I do 1 plus 5, I get 6, and if I do 1 minus 5, I get negative 4. So those are my 2 answers. And we just have one more, and we added this one on. Find all the zeros of the function. So unfortunately, I can't factor this. So I'm going to think about, first of all, what are the factors of this last number? And there aren't many to choose from. It's either positive negative 1, positive negative 7. And I put that over the factors of the lead coefficient. This is called the rational root theorem. So basically, since my denominator is 1, these are my choices. And so I'm going to use synthetic division. And across the top, I'm going to put the coefficients. And I'm going to start testing. Just have 4 numbers to choose from to test. I'm just going to start with positive 1. And this is synthetic division, so I'll bring down the first number. I'm going to multiply this way. This is what we're used to seeing as the number in the house. And then add to the next number. So 1 times 1 is 1. 1 plus negative 3 is negative 2. Now multiply negative 2 times 1, that's negative 2. Plus 9 is 7. And then 7 times 1 is 7. Plus negative 7 is 0. So the number that gives us a 0 remainder out of this list, and this is the remainder column, is a 0. So I'm looking for a total of 3 zeros. That's just another word for roots or solutions. And of the 3, I know one of them is the number 1. Well, I'm going to take these numbers now, because I divided into x to the third. This represents 1x to the second. And this represents negative 2x. And this represents just the constant 7. And to find the other 2, to make up all 3, I'm going to solve this. And it doesn't factor. So once again, you have 2 choices. You can complete the square like we did on the previous problem, or you can do the quadratic formula. And so I'll just go ahead and complete the square. So this is a review of what we did previously. Subtract 7 first. Come up with the number that completes the square, and it's very much like the previous problem. Negative 2 divided by 2 is negative 1, and negative 1 squared is positive 1. Here's the factoring, x minus 1, quantity squared, and that equals negative 6. Square root of both sides. This is going to be plus minus I times the square root of 6. And then I'm going to add 1 to both sides to get to my final answer. And so one of the answers we already came up with was 1, and then the other 2 are shown here because of plus minus. This represents 2 solutions, so we found all 3. Okay, so that is your entire review sheet. I hope this helps you. I hope you work hard on these problems, and make sure you come in on test day ready to work problems like these out. And if you have any questions, let me know.